Welcome back, and we are going to look at representing vectors with algebra. And so let's just kind of review how we thought of vectors previously. So I'm just going to draw a coordinate grid here. And previously, what we said with vectors is that, it began at a point x1 comma y1. So I'm going to represent that here. I'm going to call that x1 and this y1. And then it ended at x2 y2. Okay, and the point for that would be right there. And so our vector would look something like this, and we would give it a name v, and we'd move on with our day. We could find its magnitude, its direction, right? Its direction would be given right here by angle theta. Okay, fine. And we could even give these the initial and terminal points labels of P and Q, and I'm just going to label these as x1, y1, and x, or sorry, these were subscript 2's. Let's redo that. And x1, y1. Okay, so this is fine. Now, I want to dissect the geometry just a little bit more. I know you're like, geometry, ooh, man, I've been there, done that, and I don't want to go back. But when we were looking at vectors, right, at least geometrically, we were moving some sort of horizontal component, or we were moving horizontally and vertically, right? And so how can I represent that horizontal and vertical movement? Well, if I went horizontally here, okay, and I'm going to zoom in even more, this side of, if I were to make a triangle out of this, that length of the side of the triangle, I could find that as the space between x1 and x2, which is just take x2, subtract x1, and boom, there we have that amount. And then, so from the initial point, if I were to, move this amount in the horizontal direction, great, I'd be right below Q, but I do want to go up to Q, and so I can say, okay, look at the vertical distance, which would be between x1 or y1 and y2, and specifically, I would calculate that as y2 minus y1. Okay, so another way that I can represent vector v is in terms of its horizontal and vertical motion. Okay, much like x and y. Okay, the only thing that's going to change is that when I represent a vector, I need to use these angle brackets. Okay, to indicate that it's a vector. Normally we would use parentheses for points, and so it just differentiates a vector from a point. And so horizontally, I could say, okay, I move by x1 minus, or x2 minus x1, and then vertically I move by y2 minus y1, okay? This whole form that I just wrote out, this is called component form. And this, because it has numbers associated to it, it's very nice to work with it algebraically, okay? Let's see a quick example with that, okay? So I have a vector. V has initial point that, terminal point that. Okay, so I need to just plot this. I need to see this. So negative 4, comma 5, right there. That's initial point. Terminal point is negative 1, negative 3. Okay, so it's down just a little bit more. Negative 1, negative 3. Oops, that's negative 2, negative 3. Let's try again. Boom, there we go. And our vector V looks like this. Okay, and it says find the component form. Okay, so let's do that. Vector V. Okay, I need to figure out, what is the total horizontal motion versus vertical. Okay, and so there I see horizontally, right, I move to the right first, and then I move down. Okay, so I moved 3 units to the right. Okay, so my change there would be 3. I could do this algebraically as well. I could do this as negative 1 minus a negative 4, okay? And vertically, I would move down 1, 2, 3, 4, 5, 6, 7, 8 units. So I'm going to denote that by minus 8. And algebraically, again, I could do the endpoint, the terminal y value minus the initial y value, and so I get the same thing of 3 minus 8. Okay, so that's part A. All right, so next, standard position. Okay, this is new language that we haven't seen. Sketch V in standard position. So this just means the initial point is at the origin. Okay, so initial points at the origin. And vector v, right, this is actually describing how to move from your initial point to your terminal point. So just move 3 units to the right. So here's 3. And then I have to move down 8. And I end up with vector v being here as well. Okay. Again, a vector is just a direction and a magnitude, so it really doesn't matter where it starts. You can put it wherever you want. And sketch v with initial point 2, 3. So 2, 3 right there. And then I go to the right 3 and down 8. So 3, 3, 3, 8. So these are all vector v, just with a different starting point. Okay, so great. We have another way to express a vector. Okay, and we talked about the idea of equal vectors, meaning that they have the same direction and magnitude. Now with component form, we actually get something nicer. Two vectors would be equal if and only if their components are equal. So it's the same horizontal and same vertical motion. Okay, fine. We get a bunch of properties, a lot of them you would expect. We have commutativity, associativity, zero vector, opposite vectors, right? So just take a look at these and be aware of them, okay? A few other notational pieces that I want to mention is that the book and I, we do things differently sometimes. And just so you're aware, if you see a bolded letter, that indicates a vector, okay? It's sometimes just easier for typesetting to do the bold versus a vector with the arrow above. And the zero vector, right? We said vectors have to have magnitude and direction, but the zero vector is the only vector that we can have without direction. And we need it to make our definitions hold. Okay, so now we have several vectors, oh man, a lot of things. And we want to find each of the following. Okay, so vector r plus s, right? This is saying take vector r, which is given by -3, 6, and add to it vector s, 12, minus 7. Okay, and so then we add it, and you add component-wise. So you would do, -3 plus 12 is 9, and then 6 plus -7 is -1. Okay, and I'm going to have you try the next one. When you do this, you get -7, 14. Okay, 4s, now this is much like you might expect, but this just means -4 times the vector s, so 12 and -7, and this 4 would distribute, okay? So you get -48 and 28, okay? And now I want you to try 3q minus 2p, pause the video, try it out, resume it when you're ready to see the solution. There you go. And this last exercise is a bit of an extension. And again, pause the video, try it out, and I'll show you the answer. I won't explain it, but resume when you're ready. And here you go. This one was just meant to be a little extension activity if you felt so motivated. All right, so in this video, what did we introduce? We introduced component form, right? We talked about representing a vector as this particular form where we take the difference of the horizontal components and then difference of the vertical components, put it in these angle brackets, and then we talked about standard position too, and we saw all these different properties and made use of them.